So in this lecture, we'll cover the topic of combinations. So we already covered permutations. So if we have to know permutations and combinations, we have to do the other half, combinations. So before going into examples, I'll give you a small definition of combinations, which will be elaborated through examples. So combinations are the number of ways to select objects from a collection of objects where order does not matter. So the key point here is that we are selecting some objects from a collection of objects and order does not matter in this selection. So this will be clear through an example which I'll do next, and you'll understand what it means that order does not matter. So let us look at 3 tennis players. So let us look at the top 3 ones, which are Nadal, Federer, and Djokovic. So I just marked them N, F, and D. And now the question is, in how many ways can you select a doubles team from the 3 players? So we have these 3 players, Nadal, Federer, and Djokovic. We want to form a doubles team out of these 3 players. So doubles team will have obviously just 2 players. So we have to select 2 players out of these 3. So in how many ways can you do that? Before I cover the solution for this problem, I'll ask you to solve a question which you can easily do using what we have done from permutations. So we'll just do the problem. So find the number of permutations of 3 players N, F, and D taken 2 at a time. So this you should be able to do by now. Then I'll give you the choices. The choices are 3, 6, 8, and 12. The correct answer is 6. And we can see that if I go to the next page, what you have to do, I have 3 players and these are N, F, and D, and I have to just take permutations of these 3 distinct objects. So they are distinct or different objects, and you have to take 2 at a time, right? So you just do 3p2, right? And that is equal to 3 factorial divided by 3 minus 2 factorial. That is 1 factorial, and this is 3 factorial, or 6. And we also know that if we had used fundamental principles of counting, I'll just say that you have to fill 2 boxes, right? Because you have to take 2 objects from these 3 distinct objects at a time. So the first box can be filled in 3 ways, the second box can be filled in 2 ways, and therefore you have 3 multiplied by 2 and you have 6 ways. That is same as the 3p2, we already know that, but just I wanted to tell you again that how fundamental principles of counting and permutations are linked. So let us look at the actual 6 arrangements. What are those? I'll go down. So the actual 6 arrangements are NF, FN, ND, DN, and FD, DF. right? So we have 6 arrangements. Now we want to see how many double steam are there in these 6. So how many double steams are there in these 6? So you should be able to understand this. So is N and F and N a separate double steam? So you have Nadal and Federer, or Federer or Nadal. Does it matter whether I place Nadal before Federer or Federer before Nadal in a double steam? It does not, right? Whatever you say, the two pair like doubles team play together, so it doesn't matter whether I place one before the other. So doubles teams don't become different just because I put Federer before Nadal or Nadal before Federer. So this is only one team. These two arrangements correspond only to one team. Similarly, this one, right? Nadal and Djokovic and Djokovic and Nadal, and Federer and Djokovic and Djokovic and Nadal, Djokovic and Federer. So how many teams now are possible? 3, right? 1, 2, and 3. So you have only 3 teams possible, right? So these three selections, are combinations of 3 different objects taken 2 at a time. So this is very important. They are combinations of 3 different objects taken 2 at a time. So these are the combinations. What is the difference between combinations and permutations? Basically that the order does not matter in combinations. So order does not matter, and you have to basically just do a selection, whether it's Nadal or Federer or Federer or Nadal, Nadal or Djokovic or Djokovic or Nadal. So these two are same, these two are same, and these two are same. And this is very important, combinations of different objects taken R at a time. Let us get a notation for combinations like we have for permutations. So let us get it to the notation now. So number of combinations of n different objects taken R at a time where objects cannot be repeated is given by this notation NCR, or n coming to the top right corner and R here, or CNR. So we will use this notation, very similar to a permutation. So this NCR should not say equal to, but combination, and NPR was permutations, right? I'm just giving you the other notations just so that if you see them in a textbook you are not confused. They are still the same thing. But what are these? These are combinations of n different objects taken R at a time where objects cannot be repeated. So what are the 3 things here? Like if we had to select a doubles team, like the previous problem with Nadal, Federer, and Djokovic, how many distinct objects or different objects do you have? 3, right? So you have 3 different objects. So n is equal to 3. And for a doubles team, how many objects you have to take at a time? So the doubles team, so you only had these particular doubles teams, right? Nadal, Federer, Federer, Djokovic, and Djokovic and Nadal. So doubles team R is equal to 2 because you have to take 2 at a time. From 3 you take 2 at a time, and then without repetition. So this is without repetition. So that means that teams like Nadal, Federer, or Djokovic, so both people are repeated. So that is not possible. So that's why this particular notation is only for combinations of n different objects taken r at a time, but these objects cannot be repeated. So n cannot be repeated twice, for instance, in this case. So these are not allowed. So that's what this notation stands for. N choose r, they say. Choosing r objects out of n. This is also how it's called, choosing. So choosing r objects out of n. That is also NCR. So you just have to familiarize yourself with this. And I'll just tell you one more thing again, that permutations, order matters, and combinations, the order does not matter. This you have to take from this lecture and always keep in mind. This is the most important fact you have to learn from permutations and combinations, the whole topic actually. Permutations means that order matters, and combinations mean order does not matter. For example, Nadal, Federer, and Federer-Nadal are two different permutations, but only one combination. In combination, it doesn't matter whether n came before f or f came before n. So that's why it's only one combination, but in permutation, the arrangement matters, or the order matters. That's why nf is different from fn.